Welcome to SE Podcast Teach&Talk โดยศูนย์วิทยาศาสตร์เพื่อการศึกษาก้าวใหม่ก้าวแห่งคุณภาพเพื่อปวงชน
Greeting and welcome back to SCE Teach&Talk Spotify podcast with me, Nanapat Taupan, educator practitioner from Science Center for Education and Bangkok Planetarium. So every week, we are serving science to your doorsteps by Science Center for Education, where we will talk, share, and cover interesting, knowledgeable, and educational topics. From the first two episodes, you guys probably noticed that we were focusing mainly on the new program of NASA, which is the Artemis 1. And by this time this episode is airing, you probably heard a couple of news. So on the 29th of August 2022, where I stated that NASA paged the date for launching. However, during that day, they faced a little problem and decided to push back the launching date to the very beginning of September. And of course, after you probably heard that on the 3rd of September 2022, yet again, NASA failed to launch the Artemis 1, the super rocket. So they find another leak, the hydrogen leak on the rocket, and decided to not launch the rocket. So now, this week, the team has been reviewing and probably going to disconnect the rocket, trying to check for more hydrogen leak and fix it at once. Yet another journey has been stalling, but it's fine. It's a small step of a mankind, but a giant leap of a human still. But this week, we will focusing our talk on another thing, which is we have been talking about this planet for a very long time. So, since we have space exploration and space technology, we have been obsessed with this planet. So after a while, from counting, we have sent 20 missions and several rovers to explore this red planet. And by calling it red planet, you guys probably know that we are talking about Mars, a tiny little red planet. So last week, even though the installation of the fuel leak on the rocket, however, we got some good news on Mars. You guys might remember that 2 years ago, we launched 3 Mars missions from Earth during the intervening months. And for many of you who don't understand what intervening month is, basically it's the time where the Mars coming close to Earth. So the Mars orbital lines to the sun, around the sun, just like us, has happened to be close to Earth, which is the great timing for launching any mission to Mars, because it will take less time, less fuel, less distance, basically. So after the successful launching at Jezero crater on Mars, Perseverance mission, nobody knows, most of the people don't know that Perseverance carrying the most advanced technological piece of equipment that we ever sent out to space, to Mars this time. Also, we decided that we're going to fly a drone on Mars, which is also very exciting, the first time in human history. But little that people know, on Perseverance is also carried this tiny lunchbox size apparatus or device, and it's called Moxie. So this week, we are going to talk about Moxies and Mars. A lot of people might not know about this program at all, but let me tell you what it's about. So Moxie is a small but very, very important NASA experiment on Mars. And it has demonstrated that it is possible to manufacture oxygen on the red planet using the resources found on Mars. So now we're talking about producing breathable oxygen on Mars, which is, again, the very first time in human history that we will be able to produce our own oxygen. with whatever we find on Mars. So the Mars Oxygen In Situ Resource Utilization Experiment, or Moxie for short, has produced oxygen from the carbon dioxide in the Martian atmosphere 7 times since landing on Mars in 2021. Moxie produced around 6 grams of oxygen per hour, which is basically the same rate as small tree on Earth. And it's actually not too bad for a lunchbox-sized device, if you ask me. According to the findings published on the paper in the Journal of Science Advances. So according to Jeffrey Hoffman, which is the Massachusetts Institute of Technology professor of aeronautics and principal investigator for Moxie, quoted, "This is the first demonstration of actually using resources on the surface of another planetary body and transforming them chemically into something that would be useful for human mission." It is historical in that sense. And he's right. It is the first time in human history that we actually be able to extract or making and using of resources on the surface of another planetary to be able to use it to something useful to human mission. And this is also the first time we be able to produce breathable oxygen outside of Earth. This is amazing and this is huge, guys. So the ability to extract important resources from extraterrestrial environments is an area of ongoing research at NASA and another space agency, since every gram of material that can be produced on the site is a gram less that it doesn't have to be carried or launched from the Earth at the first start of the mission. So let's go back to the reason why we want to be able to do this. This is not just about answering the question, will human be able to colonize another planet or inhabit into another planet? But this is the beginning of something even more simpler than that. So in every mission that we carry on to another planet, or we carry on to a space station, or we carry out from Earth, basically, we have to carry it out by launching it with our rocket. It just means that we have to carry more stuff to the space. More stuff equal more loads pay. More load pay equals more fuel. And it just equals more of everything. So imagine this. If you want to be able to carry 10 tons of rice, you have to think about the logistic. You need a bigger truck. You need at least 18 wheelers, and probably many of them, to be able to carry that, which means there's much more to be going wrong. So if we can cut down on the payloads, we can cut down on many things. So the ability for us to be able to extract or be able to produce stuff outside Earth and prepare it on that planet, meaning that we have to carry less of stuff, meaning we have to prepare less of stuff, meaning the room for the budget and the room for basically mistakes will be lessened, which means good stuff. So just less thing to worry about, basically. So MIT began developing Moxie in 2014. And the experiment rode to Mars along with NASA Perseverance rover in 2022, landing on Jezero crater in February 2021. In the intervening months, Moxie has turned on 7 times during different atmospheric conditions to demonstrate that it can pull carbon dioxide from the air and convert it to oxygen. So the atmosphere of Mars itself is far more variable than Earth. And the density of the air can be varied by the factor of 2 through year, and the temperature can vary by 100 degrees. So, unlike Earth, Mars and other planets doesn't have a very thick atmosphere. We have 4 layers of atmospheres, and is also breathable for human, and quite stable if you don't count the climate change, basically the rains and the clouds and stuff. So in Mars, on the Mars atmosphere, have less density and in each area of Mars have different density of air and different composition of chemicals and airs. Plus, the temperature also vary by 100 degrees during the day and night and in different area of Mars. Therefore, during the time since Perseverance landed on Jupiter in February 2021, Moxie has been periodically turned on. So it's been turned on 7 times on 7 areas and 7 types of variations of atmosphere. And each time, it was successfully extracting the carbon dioxide and convert it to oxygen. Moxie works by sucking in Martian air, filtering it, and then using electrolysis to split the carbon dioxide into oxygen and carbon monoxide. So the device just basically sucked in the air from the Mars atmosphere, and then using the process called electrolysis, and then split the atoms of carbon dioxide, oxygen, and carbon monoxide. So it's basically nearly the same electrochemical process that used to produce oxygen and hydrogen from water in the fuel cell. It's the same thing. Moxie then purifies and combines the singular oxygen atoms into producing oxygen dioxide. So from singular oxygen atoms to O2, which is the breathable form of oxygen. So a lot of you may know that we do not breathe O, but we breathe in O2. So 2 atoms combines of oxygen to make breathable oxygen that we breathe in right now. So after splitting, it combining and purify it and make it into O2. So Moxie releases the oxygen and carbon monoxide back into the Martian atmosphere. But a scale-up version of Moxie on a future Mars mission would pump the oxygen into some sort of storage tank for future use. So for now, we only just have a very tiny size of Moxie. So they call Moxies as devices, and it fit in a very small lunchbox that carried by Perseverance after landing. And this small box can produce 6 grams of oxygen per hour, like the same rate of a small tree on Earth. And right now, after 7 times it's been turned on in different variation of Mars atmosphere and Mars area, it's been turned on 7 times, and every time it was successfully extracting and producing oxygen. And now, it just released the oxygen and the carbon monoxide back into the Martian atmosphere. But however, next time, we're going to produce it and going to store it in a tank. But we're talking about future mission where we're going to carry a bigger size of the device, or let's say another evolution of Moxie, just, bigger, better, and have a bigger storage tank as well. So in a future use, that could be providing breathable oxygen for astronauts, or something very important like liquid oxygen for the manufacture of rocket fuels. So this means we have to carry less of oxygen, also liquid oxygen, for the use of rockets or any other devices, and the breathable oxygen for human to do any space exploration and space mission outside the Earth. Assuming that the mission to Mars would include an ascent vehicle to allow astronauts on the surface to return back to Mars orbit and eventually home to Earth, and that such vehicle would use liquid oxygen and liquid methane as propellant. So this sounds a little bit complicated. Basically, in our future Mars missions, we were hoping that we can send human to deploy and do some experiment on Mars, and to be able to stay on Mars until they're done with the experiment and return back to the space rocket or space station, and then return to Earth. Therefore, whatever vehicle or the car or the rover that we use has to be refueled, and that fuel includes liquid oxygen and methane, which we hopefully be able to produce on Mars instead of carrying it with us. And, exceeding the payload. It would be exceedingly expensive to launch the vehicle that we can return astronaut back to the space station from Earth. So, like I said, less thing to carry equal less payload equal less fuel equal less money. Also, less room for mistake. So why Mars ascent vehicle propellant could be brought from Earth to the surface of Mars? 12 to 13 tons are required in low Earth orbit to every ton landed on Mars using current technology. So this means 500 tons would need to be launched from Earth orbit to transport the requirement MAV propellant from Earth for every Mars mission. So as you can see, that's a 500 tons of liquid oxygen and methane estimation to be able to do the mission on Mars and return the astronaut back to the space station and then return back from Earth. That is exceedingly, we're talking about 15 times more of what we need. Therefore, if we can use every ounce of the payloads to be able to produce our own oxygen, both breathable and the liquid oxygen for the fuel, we don't have to carry that 500 tons of fuels from Earth. We're talking ginormous amount of payload plus the money. So while Moxie is very small and it is so far still a singular experiment, it demonstrates that the manufacture of oxygen and possibly rocket fuel, which is the liquid oxygen, is possible on Mars. So right now, it's still a very small step into thinking about producing breathable oxygen and producing rocket fuel for our future Mars missions. But we already answered the question, is it possible? And the answer is possible, yes, 7 times so far. And if that process can be scaled up, meaning it can be bigger devices into producing a bigger scale instead of 6 grams per hour in a day. It's just one less thing the planners of the future Mars mission already are complicated enough to be worry about. So we will have to worry less about the fuel, about the breathable and the breathable oxygen. And to support a human mission to Mars, we will have to bring a lot of stuff from Earth, right? Like computers, spacesuits, and habitats, and all the devices for our experimental for future space exploration. So, in the future, we were hoping that this would lead to a bigger scale-up experiment on Mars and Moon, that we'd be able to produce oxygen and produce fuel for the rockets. After hearing and reading about the Moxies for a while, it's kind of surprising how far we have become as humanity. And we're talking about space technology and space exploration. It was just 50 years ago that we celebrating the first step on the moon. And now with the Artemis 1, we're bringing back people to the moon, hopefully by the end of 2029. And then the Lunar Space Station will be our another step for space exploration, but deeper. It will be a midway until we be able to go and bring human to Mars and experiment more and answering more questions and challenging more problems. But now, from this week, we already answered the questions. We have answered the question that there were water and there was a lake on Mars, and now, in the past week, we're answering, is it possible to produce breathable oxygen on Mars? And of course, ladies and gentlemen, the answer is yes, 7 times. So now the time's up. So don't forget to turn in and follow us for updates and for more information on worldwideweb.scienceplanet.org, our Facebook fan page and YouTube, Science Center for Education in Planetarium Bangkok, Spotify and Google Podcasts, Teach&Talk. And don't forget to tune in until next time. For today, let's have it. Goodbye.
Teach&Talk โดยศูนย์วิทยาศาสตร์เพื่อการศึกษาก้าวใหม่ก้าวแห่งคุณภาพเพื่อปวงชน SCE the modern co-learning center for science and ed tech for all